Hello everyone, my name is Coco and I'm going to be showing off a simple modification you can make to the standard full adder design in Minecraft Redstone that'll give you both an XOR and an AND output to this already complicated gate. So hopefully by now you know what a full adder is. If not, I'm sure you can look up a couple of videos and figure it out. Basically it's a way of just doing basic bitwise arithmetic in Redstone. So you have your A input, your B input, and your carry in, and then for outputs you have your output and your carry out. So if you add 1 and 0, you should get 1. 1 and 1, you should see the output go off, and the carry out go on, indicating a 2. Then of course if you have a carry in flag set as well, you get the output as well. Hopefully you already know how that works. If not, again, I'd recommend go look up a video on how a full adder works and exactly what it does. So I'm going to be showing off a simple modification you can make to this to get you both a XOR and an AND output from this. This is extremely helpful if you're developing your own ALU, because it condenses everything down into one gate, so you don't have to have, you know, an adder and an ANDer and an XOR array to say. So the first modification, the XOR gate, we can take the output right off of this lamp. So for both of the AND and the XOR, we want it to be independent from the carry out flag, or the carry in flag, excuse me. This is because we don't want the ripple effect of the carry in going to the carry out to affect just the outputs we want from the A and B inputs. So if you pay attention to this torch right here, you'll notice that it has the same effect as an XOR gate with its output. Specifically, the inverse has the same effect as an XOR gate. So with both of them off, we should see it off. With one of them on, it turns on. With the other one on, it's still on. And with both of them on, it turns off. This is a standard XOR output. So we're going to run this wire down by just moving this line over a little bit. So this is our normal full adder output, and then we're going to grab this output right here, and this is going to be our XOR output. So now you can see that we have one gate with very minimal modification to it, the same size roughly as the normal gate. And you can see that not only do we have the adder effect on it, but now also we can grab the XOR output from this one. So the XOR is off, carry out is on. Yeah, hopefully you can see that that's all correct. So now the AND output is going to come from this AND gate that's right on the front of the gate here. If you look at the A and the B inputs, you can see they're both running into torches and into this redstone, which means this redstone will only turn off when both of the inputs are on, and then of course inverted out here with this torch, which means this redstone will have the AND effect from the A and the B inputs. So if we turn A on, it won't turn on. If we turn just B on, it won't turn on. And if we turn both of them on, you'll see that that light turns on. So now we have an AND output from the exact same gate, obviously because there's an AND gate embedded in the full adder. This is also independent of the carry in flag. So again, we are all good there, regardless of the inputs. You can see that it should still be off. Perfect. So now all we have to do is just run a simple little wire to get this one down here. And just like so. Perfect. So now we have another modification to the same gate. This wire does actually go outside of the normal size of the gate of the full adder, but it is still tileable because it doesn't interact with anything over here with the positioning of these blocks. So it is still tileable. I'll show you a quick example over here. You can see I have the same kind of full adder implementation. There's the A line, there's the B line. And you can see that this AND line does not interact with the redstone on the next full adder. But that's another project. So now you can see that we have a full adder with 3 different outputs. One for the normal function of the full adder, one for the XOR, and one for the AND. This hopefully should be able to save you some room in your ALU that you're trying to develop. And yeah, thanks for watching. Let me know if you have any smaller designs for this or any improvements to be made. I'd love to share. Thank you.